Hello, everybody. Have you ever wondered how your brain creates a memory from scratch? Today, we'll explore the intricate process of how individual G are formed, the dynamics of G waves, and what drives our initial emotional responses to new experiences. Let's dive into the fascinating world of neural formation and connections. So, first question or topic, the birth of a Jew. How it all starts. A Jew often begins with sensory signals. For instance, when a newborn baby first sees a tick ticking clock, the visual input creates visual G waves, which are projected into the brain's processing regions. This input not only helps the baby see the clock, but also starts building a view of its image. If the clock is ticking, auditory signals generate auditory G waves, creating a corresponding sound-based G. Since the sight and sound occur simultaneously, the brain links these two Gs through simultaneous activation effects, forming a connection between the image and the sound. But there's more. Sensory G waves don't act alone, they interact with instinctive G, triggering emotional responses like curiosity or fear, and even influencing behaviors such as moving toward or away from the clock. So, how does your brain process sensory input? The journey of a G wave is fascinating. Sensory signals like sights or sounds are first processed in the G wave manifestation region of the brain, where they branch out in various directions. First, forming new Gs, for instance, creating the clock's image G. 2. Activating instinctive G, leading to emotional responses like joy, tension, or fear. If the clock is deemed safe after continued observation, the brain forms a harmless experience G linked to the clock's image G. Over time, this connection stabilizes while the initial fear-related G connections fade away due to lack of reinforcement for the baby. Yes. So, why familiarity reduces fear? Image seeing the same clock again. Imagine Imagine seeing the same clock again. The second time, the brain prioritizes the image G and the harmless experience G, minimizing the fear response. This demonstrates the attraction principle of G, that is, activated Gs attract G waves, shaping their pathways and influencing emotional reactions. But what if you don't immediately recognize the clock? At first, there might still be a moment of tension. What's that? Because your brain hasn't yet activated the relevant image G. Once it does, the harmless experience G quickly follows, calming the reaction. Interestingly, Even if you don't consciously recognize the clock, you might still remain calm. Why? The environment's G could activate, connecting with the harmless experience G and bypassing the fear altogether. Why do some environments feel safe? Sometimes we find ourselves relaxed in new settings. This can happen because the environment resembles places we've encountered before. Our brains activate similar environment cues, which may already be linked to harmless experience cues, giving us a sense of comfort and familiarity. Here are some key takeaways. 1. Cue formation. It starts with sensory input and builds through simultaneous activation of related cue. 2. Cue wave dynamics. Sensory and instinctive cue waves interact to create emotional responses and behaviors. 3. Reinforcement methods. Continued exposure to harmless experiences strengthens positive cue connections, while fear-related ones fade. 4. Environmental familiarity. Familiarity. Oh, what does this word? Similar to activations can provide comfort even in new situations. So what's next? In the next chapter, we'll dive into the dynamics of G-Wave's energy. What drives activity? How does simultaneous activations shape connections? And can we reshape G's to change behaviors or emotions? Stay tuned to unravel more of your brain's mysteries. If this video blew your mind, hit that like button. Blew your mind, hit that like button and share it with someone curious about neuroscience. Don't forget to subscribe for more deep dives into the fascinating mechanisms of the human brain. See you next time. Bye bye.